This is your very final play posit for the year. And in today's lesson, we're going to be taking the material from the very beginning of the year when we learned about the different gas laws, the material from last lesson where we learned about the ideal gas law, and the material from the last unit where we learned about stoichiometry. And we're going to just kind of combine them all together so that you can prepare finally to answer all of those questions regarding your soda bottle boat that you'll be making in the next week. So before the end of today's lesson, you just need to make sure that you understand how to complete stoichiometry problems for gases when they're not at standard temperature and pressure using the ideal gas law. So the example that we're going to walk through together involves the reaction between methane gas, and that's being burned in oxygen. This is like the natural gas that we use in our Bunsen burners. You're going to be given information here about the methane gas, as well as information about the carbon dioxide, one of the two gases that you probably remember is formed during these combustion reactions. You'll use the information given along with the information given from the product in order to actually complete two ideal gas questions and a stoichiometry problem as well. This is very similar to the calculations that you'll be doing in the extension calculations of your soda bottle boat lab that you'll be completing. So the first thing that we always do is, of course, just identify the variables. And here we're going to identify not only just what property is being measured, but also for which of the two gases that is being referred to. So our 2.80 liters is the volume of our methane. The 25 degrees Celsius is the temperature of our methane. And the 1.65 atmospheres is the pressure of our methane. The 2.50 atmospheres is now the pressure of our carbon dioxide gas, and the 125 degrees Celsius is the final temperature of our carbon dioxide gas. We're going to start with the gas that we are looking at as a reactant, and we're going to do this because we're given the most information about that. You probably noticed that because we have the V, the T, and the P, and because the R is a constant that we always know, we can actually already use the ideal gas law to solve for the number of moles of the methane. Once we know number of moles, of course, we're going to go right into stoichiometry, since that is the conversion that we always use with the number of moles. And that is actually going to let us determine the number of moles of carbon dioxide formed. Once we know the number of moles, that gives us a third variable down here in the green box, and then we would actually be able to do a second PVNRT problem. This is actually the most complicated problem that we're doing together, and then you're going to see some different examples that are very similar, but using just different types of numbers that you'll be working on with your partner. So if we start with our ideal gas law, the one that we looked at yesterday, we know that we can manipulate that to solve for the number of moles of methane. If you look at how I stuck each of these numbers in, you should have noticed that your final answer should have been 0.189 moles of methane produced. Once we know the number of moles of methane produced, we can now do stoichiometry to determine the number of moles of carbon dioxide that would be formed. Here's our balanced chemical equation, which, if you notice, it is a 1-to-1 ratio of methane to carbon dioxide. So even though the number isn't going to change, we are going to use that 1-to-1 ratio just to see that we're now in moles of carbon dioxide instead of moles of methane. Take a moment, consider how would this change if instead of using the methane as my initial numbers, I had given you the information for oxygen gas. What would be different? Once we have our moles of carbon dioxide, we're going to stick that back into PVNRT, but this time you'll notice that I manipulated it differently, like we did in some of those warm-up problems, in order to determine the volume of carbon dioxide. And the volume of carbon dioxide here you should have gotten was 2.47 liters. Hopefully by walking through this example together, you now see how the two pieces of the puzzle really fit. We can use both stoichiometry to determine how one substance reacts with another substance, and then we can use our ideal gas law to determine how each of those two substances is really influenced by the properties that they're within. So that's our temperature, our pressure, and our volume, because we're, of course, working with gases. Now that you have completed this play posit, you should be ready to go for the other summary investigation, as well as the practice problems that are also available within the module. Once we have all of those things finished, we'll finally be ready to get started on that project for the rest of the year. Let me know if you guys have any questions.